We're going to find the zeros of this exponential equation here, this exponential function. Sorry. So we have made y 0 because we remember that a 0 is the x coordinate when y is 0. So we made the y 0, and we're going to solve for x now. We looks like we need a logarithm. We've got 2.5 to the x. When our variable's in the exponent, we usually need to use logarithms to solve the equation. So we're going to make both sides a logarithm. You can make both sides a log base 10, remember, or you can make both sides an ln. Doesn't matter. We're going to use our power property, move our exponent to the front. So we have log x times log of 2.5 is equal to log of 5. And then we can divide both sides by log of 2.5. Now this is not the only way to solve this equation, but this is definitely one. So this is the exact value. If we open our calculator, we could get an approximate value. Log of 5 divided by the log of 2.5. The log of 5 divided by the log of 2.5 is approximately 1.756. Approximately 1.756. We're going to get in the habit of rounding to 3 decimal places. We could have used an ln. We could have just changed the sentence to a logarithm and used change of base formula. That might ring a bell too. So we're going to look at this graph, and we're going to answer the question. What can you say about A, B, C, D, P, and Q? So I've given you 3 exponential curves. The first one is y is equal to P times Q to the x. The second one is y equals C times D to the x. And the third one is y equals A times B to the x. So let's see. So what we can say is first that all the constants are positive. And the reason why we know that is because with exponential functions, the base will always be positive. Let's make a note of that. Base always positive. It's always a positive number other than 1. And we also know that their initial amount, the initial amount here, the A, the C, and the P, the initial amount is represented on the graph by the y-intercept. And I see that all 3 y-intercepts are above the x-axis. So I know that all constants are positive. Okay, so what I know, that since I realize that the initial amount, the A, the C, and the P, represent the y-intercept, and I see that these two cross the x-axis, the y-axis, excuse me, at the same place, then that means that A is equal to C. It also means that A, which is equal to C, both are less than P. Because notice where P is. P is way above A and C. I know that B is in between 0 and 1. And the reason why I know that B is in between 0 and 1 is because we have a decreasing function, a decay function. And lastly, I know that D and Q are greater than 1 because I see exponential growth in those functions. So we're going to put that we know that B is in between 0 and 1 because I see the graph decreasing, and D and Q are greater than 1 because I see the graph, both graphs decreasing.